Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfazira and today I would like to present my final year project report. My title is FPGA based digital control for BLDC motor. My supervisor is Dr. Afarul Razi bin Abu Bakar and my two panels is PM Dr. Dur Muhammad Sumro and PM Dr. Wahyu Mulyo Utomo. For the content, the slide will be divided into 4 sections of introduction, literature review, methodology and preliminary result. So for introduction, it will consist of background of study, problem statement, objective and scope. So for background of study, I discuss about the comparison between brush DC motor and brushless DC motor. For brush DC motor, the advantage is widely used in application of simple and easy control system, and it is also low cost. However, disadvantages of brush DC motor is that it requires periodic maintenance, frequent replacement and also produce sparks which in result of electric noise. On the other side, brushless DC motor does not require a brush and a switch, therefore it is more efficient. It also offers controllability, high durability and low electric noise generation due to the brushless feature. For the problem statement, I discuss about the disadvantage of analog control, which are influenced by temperature variation, component aging, high cost and lack of flexibility. So how to overcome this? I use digital control, which allow flexibility for changes to higher function and system alteration, and also FPGA can be programmed according to the desired operation. Conventional motor such as induction motor have low efficiency, require high maintenance and produce electrical noise. Therefore, for this project, I use BLDC motor which has low electrical noise generation, low cost and more efficient compared to brush DC motor. There are two objectives. Is to design 3-phase inverter to control brushless DC motor. Next is to control the speed of BLDC motor using PWM controller with closed loop system using FPGA. There are 3 scopes, which is design a 3-phase inverter for BLDC motor using Altera DE170118 board. The control technique for controlling the speed of this BLDC motor will using a PWM technique, and Quarters 2 software will be used to program FPGA in controlling the speed of the BLDC motor. Next, for literature review, it consists of the main components for this project, which is BLDC motor, digital controller, FPGA and inverter. BLDC motor is categorized as AC synchronous motor due to the generated magnetic field at stator revolve at the same frequency with the rotor. Brushless DC motor has 3 classifications, which is single phase, 2-phase and 3-phase, but the commonly used is single phase and 3-phase. The basic component of BLDC motor are permanent magnet rotor, which is this one consists of north and south magnet, stator and rotor. The third one is electronic circuit to control the phases of rotor winding. There are 3 types of rotor winding, which is this one, surface mounted, embedded and inserted. This is the BLDC motor operation, which the main principle of the motor operation is the attraction and repulsion between magnetic poles. If the current flow shifts to an adjacent winding, it will cause the rotor to move. Therefore, the rotor will follow the rotating field if each winding is charged sequentially. Next, for analog versus digital control. Analog control works and processes a continuous value within a certain interval of frequency. However, in digital, it involves in using an intermediary binary language to process any computation made. The advantage of analog is it is inexpensive and robust. The disadvantage of analog is it is influenced by temperature, component aging, and limited application. On the other side, digital controller provide high flexibility and can perform a complex computation. However, the feedback signal resolution is limited. Finite word length will affect the accuracy of converted signal, and time delays in control loop due to the computation of control algorithm by the processor. This is the example of FPGA board used. The working principle of FPGA requires a VHDL program to be written in order to generate PWM signals. The advantage of FPGA is high customizability, a high processing performance in terms of speed compared to DSP, compared to digital signal processor. FPGA also perform faster calculation compared to DSP, and it is reusable every time a change was made. There are few types of FPGA in the market, which are Spartan 3E, Spartan 3AN, Spartan 6, Basis 2, and Altera 270, which is going to be used in this project. Next, I discuss about DC to AC converter, which is an inverter that is a semiconductor-based device that convert electrical energy from DC to AC. There are few switching devices used for this inverter, which are BJT, MOSFET, IGBT, and force commutated thyristor. There are two types of inverter, which are single phase inverter and three phase inverter. For this project, we will be using a three phase inverter with 120-degree commutation. This is the example of inverter used for this project, which we will be using MOSFET as a switching device and connected in three-phase H bridge. For methodology, it will consist of block diagram and flowchart. There are two block diagrams in this project, which are the first one is the electric drive block diagram, and the second one is the block diagram for the system. Any electrical appliances that involve in using a system employed for motion control are called drive. So this is the typical block diagram for electric drive system. The second one is the block diagram for the system, which a DC source is fed to a three-phase inverter. This inverter will be using a MOSFET as switching device. The coils for BLDC motor is connected in star connection, and this voltage sensor is used to supply 5 volt to the FPGA. FPGA will use to generate pulses to drive MOSFET switches. However, before it reaches to inverter, it will pass through motor driver to boost the voltage for the input of inverter. For the flowchart, the first step is to set the reference speed. Next, from the reference speed, it will sense the actual speed, and this technique will compare the duty cycle and the back EMF waveform. Two levels of duty cycle will switch between low and high to determine the speed regulation based on the compact speed error from the previous step. FPGA will work on the error and generate output in form of PWM signal for the three-phase inverter. So the PWM signal fed into the inverter will decide which winding of BLDC motor is going to be energized, hence driving the BLDC motor according to the reference speed. Next, for preliminary result, it will consist of the circuit design and the result. The circuit design is simulated using MATLAB according to this circuit model. The DC voltage supply for this circuit is 500 VDC, and we are using 6 MOSFET module as switching device rated at 20 ampere current. The rated speed for the motor is 3000 RPM. The aim of this simulation is to analyze speed, frequency, and voltage of the supply. So these are the switching process for BLDC motor. For the switching process, only two phase of motor is excited at one time. It conducts on for 2 switching devices in each 60 electrical degree performing 2 conduction phase, which is why we are using 120 degree commutation. Then from here we can see that the switching pulses are fed into the inverter and the motor will drive accordingly to the switching pulses. Several operating condition is conducted to verify the control scheme to analyze the frequency and voltage generated. So we try to simulate the circuit using different value of reference speed, and we use the data obtained to analyze the pattern of each parameter. And this is the switching pulses that is fed to the inverter. There are 6 switching pulses as according to the 6 MOSFET device used. So this is the data obtained from the simulation. We try to simulate the circuit with different value of reference speed. As the speed increase, the frequency of the motor is also increasing. However, we can see here when the reference speed is reached 3000 RPM and above, there is no significant changes to the frequency. This is due to the motor has reached its maximum speed. So this is the data obtained from the simulation for analyzing the voltage. The same pattern we get from the voltage is that it is increasing as the reference speed is increased. We can also see that the voltage of this motor is constant when the reference speed reaches 3000 RPM. This project is expected to have result as follow, which is design a 3-phase inverter for BLDC motor. Next, manage to control the speed of BLDC motor using FPGA, and finally is able to analyze the different speed control of BLDC motor from the PWM technique. The overall conclusion for this presentation is I have able to understand the switching sequence for BLDC motor and able to analyze the speed control of BLDC motor using PWM technique. And the other 2 expected result will be continued in PSM2. So that's all from me. Thank you.